Yo, what's up, guys? Merry Christmas and happy holidays. Just want to say I'm still thinking about you. I will. Sounds a little weird, but yeah. All right. Also, today is gonna be a little bit of a freestyle of it. It's my favorite. Okay, and I'm not really sure who the audience is, but I'm gonna cater it mainly towards high school students and below. Okay, but yeah, you'll see this in these topics come up again if you pursue further math. Okay, all right. So the topic, what does it mean to cancel out? And I know this comes up a lot in math class, right? And the short answer here is it depends on the operation that you're doing. Okay, so for example, if I had some problem, like if I told you to say, if I said solve a problem like this, right? Teachers would say, oh, divide both sides by 3, and then the 3's cancel out, and then you get x is equal to 7. Okay. Um, Another one, like if I gave you something like this, x minus 3 is equal to 14, and then to solve for x, teacher would say, oh, add 3, and then these 3 cancel out, and then x is equal to 17. Okay. So here cancellation was used differently. Okay. So um, once again, it depends on the operation. Oh, you know what? Just for kicks, one more. Okay. Like if I did something like this, sorry, change it up with y. Okay. Shout out to my first name. Okay. Like y over 7 is equal to 10. And then to solve for y, it would say you multiply both sides by 7. Okay. And then this cancels out and you get y is equal to 70. Okay. All right. So here, once again, depends on the operation, right? So in this case, in this example, when we added 3 on both sides, canceling out meant getting this thing called 0. Okay, more formally speaking, that thing called 0 is called an additive identity. Okay, and what that is it's supposed to be some guy, right here it's a number, such that when you add it to somebody else, the result should be nothing. Like it should be unchanged. So it doesn't do anything to that guy under this thing called addition, this operation called addition. Okay. Um, yeah. Okay. So, but in this example, here when we canceled out the 3's, what was involved was this thing called the multiplicative identity, right? So this turned into 1. And this thing, it plays a very similar role, but where it basically you when you divide by 3, you're technically multiplying both sides by 1/3, this multiplicative inverse of 3. Okay. And what that is another way people say this is called the reciprocal. And basically, uh, that gives you this thing called 1, multiplicative identity 1, right? And what he's supposed to do is that when you multiply anything by this thing, it should leave the guy unchanged. Okay, so yeah, that's what this 1 means. Cool. Yeah, and then same thing, right? If here in this final example, if I said y over 7 is equal to 10, and then to solve this equation, you multiply by 7, what you're really doing is you're multiplying by 7 because that's the multiplicative inverse of this thing called 1/7. Low key, when you're dividing by 7, right, you're multiplying by 1/7. Okay, and yeah. Okay. So, and then also another thing I want to talk about that I didn't mention here, additive inverse. Okay. So opposite numbers. So teachers say this a lot when someone's like, oh, what's the opposite of 4? We say it's -4. Okay. But if you are considering these other operations, right? Multiplication and division, right? I say this in asterisk because it gets more complicated if you go up and take a class called abstract algebra, and then they say, oh, is division really an operation or whatnot? But the idea is that you could say that these are opposites. Teachers call these opposites, but in a very similar sense, you could also say that 4 and 1/4 are opposites. Okay. Another example, if I say 3/7 and 7/3, they're opposites. Okay. Or 7/3 and -7/3. So this is a little kind of dangerous to use this kind of word. Okay, and I feel like when students level up, right, and they start seeing more of multiplication division, then this becomes a little misleading, okay, because you have to now take into consideration opposites with respect to this multiplicative identity and inverse, okay? So once again, just to recap, these are opposites because when these interact with this operation called plus, this gives you, just do it here, 4 plus -4, that equals 0, and that's called the additive inverse, okay? And then once again, these are opposites because when these interact with this thing called multiplication, 4 times 1/4, you get something called the multiplicative inverse, which is 1, okay? And then similarly, 3/7 times 7/3, multiplicative inverse 1, and then lastly, 7/3 and -7/3 are opposites. They're called additive inverses, actually. Okay, that's more proper to use. Okay, and these are multiplicative inverses. Sometimes they use the word reciprocals. Okay, and yeah, this video is probably quite trash, but it's okay. If you understand what I'm saying, congratulations. That was it's quite a big feat. Okay, and if you have any confusion or questions, please let me know, and I'll redo this. All right, guys. Once again, happy holidays, and hope you're well. Okay, see ya.